I'm Rajesh Uppal, Director IDST. We bring sharp insights and foresight on defense, security, and emerging tech. Let's dive in.
Imagine standing on the moon, gazing back at Earth, and realizing your spacecraft has no GPS signal, no satellites overhead, no navigation grid, just you, your instruments, and a 6-second delay from mission control. That's the challenge humanity faces as we prepare to live and work on the moon. And now, a new race has begun, not to reach the moon, but to map it from orbit. Welcome to the dawn of Lunar GPS, the next great leap in space infrastructure. For decades, systems like GPS, Galileo, and Beidou have guided us across Earth with pinpoint accuracy. But on the moon, it's a different story. There's no navigation network. Rovers depend on onboard sensors and Earth-based tracking, methods that are slow, imprecise, and risky for future astronauts and autonomous machines. So spacefaring nations are working towards something extraordinary, a dedicated satellite constellation around the moon that can provide precise location, timing, and communication, just like GPS does for Earth. Leading this charge is China, with a bold plan for a 21-satellite Lunar Navigation and Communication System, or LNCS. It's an ambitious blueprint unfolding in 3 carefully planned phases. The first stage launches just 2 satellites, enough to maintain constant coverage of the lunar South Pole, a region rich in water ice and critical for future settlements. Then, 9 more satellites will join, expanding the network's reach. And finally, by the 2030s, a full constellation of 21 satellites will orbit the moon, covering nearly 3/4 of its surface with high-precision navigation. What makes this possible isn't just scale, it's engineering genius. These satellites won't orbit like Earth's GPS network. Instead, they'll use frozen orbits, highly stable elliptical paths that take advantage of the moon's unique gravity. This means less fuel, longer lifetimes, and continuous coverage even over shadowed craters. Their navigation signals are specially designed to handle the moon's rugged terrain and slow rotation, avoiding interference that would cripple Earth-based systems. And with autonomous onboard processing, they can keep running even when Earth contact drops out for minutes at a time. But China isn't alone in this celestial race. Japan is planning an 8-satellite network modeled after its quasi-zenith system, optimized for constant coverage of the lunar South Pole. Europe, through the Moonlight Initiative, is building a commercial model, public-private partnerships that could one day offer positioning as a service for science and industry. And NASA is developing LunaNet, a hybrid network that can use both lunar satellites and Earth's GNSS signals, forming an interoperable Earth-Moon positioning grid. Why does all this matter? Because the moon is about to become busy. Rovers, landers, construction robots, and mining systems will all need centimeter-level accuracy to operate. Lunar GPS will make it possible to land precisely near resource sites, build infrastructure autonomously, and coordinate multiple missions without delay. It will even support science, mapping moonquakes, studying gravity anomalies, and synchronizing telescopes across the lunar surface with atomic precision. Of course, the road ahead isn't easy. The moon's gravity is uneven due to dense mass concentrations called mascons that pull satellites off course. There's no atmosphere, meaning signals travel cleanly but reflect harshly off the surface, creating confusing echoes. And there's the radiation problem. Without Earth's magnetic shield, satellite electronics must be built to survive years of exposure in deep space. Even defining time on the moon is complex. We'll need a new standard, perhaps a lunar time, to synchronize operations across worlds. Beyond the technology lies geopolitics. Whoever builds the first working system will shape the rules for lunar navigation, standards, frequencies, access rights, and maybe even costs. Control over a lunar GPS could mean strategic influence over mining zones, communication links, and scientific missions. In short, this isn't just a race for technology, it's a race for leadership in the next space economy. By the 2040s, experts expect multiple interoperable constellations to circle the Moon, offering seamless navigation from Earth orbit to the lunar surface. This network will be the invisible backbone of a growing lunar economy, enabling construction, exploration, and trade beyond our planet. Just as Earth's GPS revolutionized life here, lunar GPS will revolutionize life out there. The Moon is no longer a distant destination. It's becoming a navigable world of its own. And with every satellite launched, we're not just exploring space, we're building the framework of a cosmic civilization. The era of lunar GPS is dawning, and it will guide humanity's next giant leap.
Thanks for watching. Subscribe, follow, or visit IDSTH.com for more cutting-edge defense and tech insights. See you in the next one.